And this is section 4.3, page 185, 4D, where, I'll just show you the instructions, graph each piecewise function. And in order to graph the piecewise function, you have to figure out a bunch of stuff. You have to figure out the vertex, you have to figure out maybe the intercepts or the slope or something like that. But what they've done here is they've given you the I of x, also known as y, equals this stuff in this region and this stuff in this region, and this is an absolute value function. So if we turn it into a piecewise function, remember we turn it into its two variants, the x minus 4 and then the minus 1 times x minus 4, this is me putting it in brackets, x minus 4. So minus 1 times x minus 4 is minus x plus 4, you know what I mean? Anyways, so there's two varieties on this, and there's two varieties on that, and one of them, one set of variety, shall we say, applies where x is less than 1 and the other where x is greater than 1. Let me show you how you go about this. I'm going to write down, first of all, I'm going to put the graph over here. Make sure it's nice and big so that you can see how this all comes together. 1, 2, 3, 4, 5, 6-ish. Not going to be too precise here. You get the general idea. That's the general idea. So let me write this stuff down here. It's awfully difficult, but we'll keep it up here in the corner. So it says I of x, which is a nuisance on its own, equals a couple of different things. It equals the absolute value of x minus 4 when x is greater than or equal to 1. And it's the absolute value of x plus 2 when x is less than 1. That is a severe pain because we've got two things. So let's just think about this for a sec. First of all, x equals 1 is a bit of a, shall we say, important line. So I'm just going to trace it in here so we can keep it in the back of our head. It's going to be a point where things change. X equals 1. This is the function that's relevant over here on the right hand side of it where x is greater than 1. I'll label that x, y, make that easy. And this is the function that describes it over on the left hand side where x is less than 1. So let's take this here. Y equals the absolute value of x minus 4. And we've got this other one here, this y equals the absolute value of x plus 2. And we know, oh, whoops, straight line there, absolute value, there we go. So this is the one that's relevant where x is less than 1. And this is the one that's relevant where x is greater than or equal to 1. So we'll just keep that in mind. I should have reversed these the other way. That way it would match where they show up here, but I'll just be difficult. I'm going to just underline that with some green and this with some yellow so we can keep track of the logic as we go through this. So when we make this into a piecewise function, we already know the restriction x is greater than 1. So let's turn this into its two different equations. One is x minus 4. And the other one, y equals the negative of this whole thing. So minus 1 times all this gives us negative x plus 4. So these two equations define this part of the function and are relevant where x is greater than 1 or over here on the positive side. I'm just going to, there we go. There's the positive side. We'll put that in yellow, and the negative side starts over here, or the other side starts over there, where x is less than 1. So, in this equation, we must first find a vertex, and then we will look at the slope, and then we will graph it. So what's the vertex? The vertex over here, I'm going to draw a line down the middle here. The vertex over here is negative c over b, comma, d. And if that's the vertex of this, negative c is negative negative 4 over b, and b is 1. So it's just 4. Remember, it's negative 4, and that's why I've got positive 4. And D, that's plus 0, so it must be 0. So that's my vertex. So 4, 0, 1, 2, 3, 4. There's the vertex of the yellow. If that's the vertex, I just need to do these two lines here. So y equals x minus 4. The slope is positive, and it's positive 1. The slope of this part of the line is negative 1. And I'm only going to go as far as that line, because that was a restriction, right? This absolute value business only holds where x is greater than or equal to 1. So it only goes as far as that spot right there. Now we're going to do the same over here and break it into its components. Y equals x plus 2. And the minus version of all that, and if we multiply this junk here by minus 1, we get y equals negative x minus 2. That's minus 1 times all that stuff. So these are our two components. What's the vertex over here? The vertex is minus c over b comma d. And minus 2 over 1, so minus 2. And there's nothing out here, so that's a 0. So minus 2 there. That's our vertex. Our slope, as it turns out, is 1 or minus 1. So we have a vertex here. We know it opens up because it's positive. There's nothing here. So it's going to look like this. It's only going to go as far as the 1. And then that's going to go up this way. And we have a great big W. So we can see that the domain spans all the real numbers, and the range is from 0 up, and the intercepts, the x-intercepts, are at these 2 points here at the vertexes, or vertices, and there is a line of reflection here at 1 that was given there. So virtually all of these that have the double functions, what you end up is a double V, which in English is known as a W.